my pleasure to introduce Mr. Abhinav Gupta. Mr. Gupta is the CEO and co-founder of ActiveBuildings. Coming with an engineering and research background, he holds Ph.D. from National University of Singapore. He has worked on various projects related to 3D printing and implantable systems and communication systems. He is keen on creating the future of buildings in urban Asia that provide comfort. Mr. Gupta is also an advocate for improving indoor air quality and has developed a sensor. This product has received the RESET certification, global standard for healthy building. He has written several articles on green building, smart building, and energy efficiency. Today, Mr. Gupta will briefly overview us about fresh indoor air, best perk for employees today. So without further ado, please join me in welcoming Mr. Abhinav Gupta.
Quick background, and I'm very grateful to have followed up on the presentations of everyone on the panel today, who have touched upon a lot of points, excellent points that needed to be identified for the interest of all the audience. But a brief introduction. In addition to Darshana, I run and I've founded. In fact, we've also developed a lot of things at Active Buildings, and we work with solution providers across the world in identifying what works best in the different conditions that are available in the world. No two buildings are the same, no two offices are the same, no two geographies are the same, and the right kind of constraints need the right kind of solutions. And what we do with our efforts, with our solutions, is that we test, we monitor, we analyze, and then based on the constraints that we have observed, we then fix the problem. It can be from some of the more hyper-local problems, as Priyanka mentioned earlier in our conversation. We worked with schools that were impacted negatively due to outdoor dumping, illegal dumping, or just random dumping on the streets, causing high ozone and high NO2 levels. Identifying such problems and then solving them for the outdoor environment as well as solving them for the indoor environment is something that we really specialize in. But today I'm going to talk something very specific that I have observed in the last few months, specifically in the last few months, in particularly in this year, as heat grapples, climate change grapples with everyone and every environment, and as more and more people are spending indoors with the ACs and the air conditioning. How do we make people feel better? How do we make people breathe good air despite them being cooped up in indoor environments with temperature regulation at all times? And what is the cost of this? Because a lot of times we hear that we've seen that engineers and engineering departments across India, even though they're not measuring the air quality, they know that something is wrong. They know that the ventilation is not enough. They know a little bit that yes, it is polluted air, but there are constraints. There are constraints that maybe they're in a tenant building. Maybe they don't have enough time, or they do not have space to accommodate some of these solutions. And many times the question is it really worth the cost? So that's what we're going to discuss today, how fresh indoor air is actually the best perk for your employees and for your team members today. And in this context, I'm going to specifically discuss the case study. It is something that we practice with other employees, with other offices, but we also practice with our own employees. And today we are going to look into how we managed to give fresh air to our employees. What was the context behind it? What was the cost behind it? And how do we manage all these kind of constraints? So, let me give you a little bit deeper context into what we are talking about. We're talking about Mumbai city. We are based out of Mumbai, and this year the media has focused themselves on Mumbai's air pollution as well, and they've highlighted how the PM10 and PM2.5 levels are very high. So, in context, on an average, around 278 micrograms per meter cube, 423 micrograms per meter cube is what is the outdoor air quality in Mumbai. Reflecting that indoors, along with obviously the particle matter that is coming from outside, and in many cases ozone and NO2 also coming from outside, indoor pollution creates CO2 levels. And as Alejo from Kiter also pointed out earlier, it's quite a bigger problem. So what was the issue here? Close to 1500 ppm of CO2 was observed in our office, a 6000 square feet space with almost 77 people working full time in that space, and a CO2 levels consistently between 1500 to 2000 ppm. um this has already been touched upon before, but I'm going to reiterate. PM 2.5 creates a lot of challenges. Ideally it should be under 15 micrograms per meter cube, but it was approximately 260 in our office, and this has a lot of issues in short term exposure as well as long term exposure. And I think all of us know this very well, but it's always good to reiterate what are the bad impacts of PM 2.5 on human health in a short term or in a long term. The second and often overlooked part in India, where if an office space is designed for 100 people, sometimes to optimize the space, we cramp in a lot more people than expected. It causes a lot of havoc, obviously, in terms of space, but also in terms of the kind of air we are breathing. So wherein CO2 should be indoors below 700 ppm, and I'm not talking about CO2 being monitored at the duct level. At the duct level is different, but actually where people are breathing, CO2 being heavier than air, it settles down. So it's important to monitor it where the people are sitting, and not necessarily at the duct level. When we monitored it, we found it at 1500 ppm. Again, short-term exposure, very common, frequent headaches, dizziness, lack of focus, reduced cognitive function, very, very, very well known. But the long term syndromes, right? It has effect on your cardiac health. It has effect on asphyxiation, CO2 poisoning, and of course the very well known sick building syndrome. Of course, all of this, as being known, it has disadvantages to your operations. It has disadvantages to your day-to-day running, and they come in many forms. They come in the forms of frequent absenteeism, frequent health issues. In fact, ICICI Lombard in a lot of their studies claimed that 4 times health benefits are being claimed in offices due to air and water related damages to their health. And this comes at a significant disadvantage to the company. And Indian businesses lose approximately $97 billion annually due to bad air quality indoors as well as outdoors. Now, what is the solution, right? Good to know that the office has bad air quality, outside is bad, inside is bad. All of that is very well understood. But what is the solution? So the first thing is that, the first and most important thing is to augment your ventilation system. And we are not talking about grade A buildings necessarily. We're talking about even smaller spaces, 1,000 to 2,000 square feet spaces, up to 3,000 square feet spaces, which are 90% of the offices in India. These are leased out tenant spaces where doing heavy changes into the infrastructure is not always possible. So many people stick to split ACs, they stick to cassette ACs, and they're not able to fulfill a proper air handling unit setup into their system, right? A complex HVAC system is not always possible, and many times cassette ACs and split ACs are used in 90% of the commercial spaces in India. So when you do that, you're actually restricting a lot of the airflow, and for that, the one thing that needs to be put into the design strategy is a ventilation management system. How much fresh air is being brought from outside, what is being done to that fresh air, and how are we managing the flow of that fresh air into the facility. Now, when you bring in fresh air, there are a lot of concerns from the engineering side of things. One is, what is going to be my electricity challenges? My bills are going to go higher because fresh air is hot. I need to cool it down. So how is it going to negatively impact my commercial and my bills? And the second is, fresh air from outside is polluted. So why are you bringing that air inside? Why are you making the air inside even worse? And to filter that air is going to take a lot of energy. So how are you going to work on that? And that is basically, onto the PureChi HEPA filtration system. That is, we are working with Pure Living, the company called Pure Living that's based out of US. So we are working with them to engineer solutions in India, and this is the one of the solutions that we've installed in our office, and we've also installed in multiple other settings. But today we will talk about the data coming from our office and our systems. So this HEPA filtration system brings the air from outside. It passes through a heat recovery system, so it's completely thermally neutralized. So a 41-degree fresh air is thermally neutralized to bring it down to 26, 27 degrees. Then it is passed through a 4-stage filtration system, which includes a pre-filter, a fine filter, a HEPA filter, and a chemical filter that will be customized based on the air quality around them. So, again, as Priyanka mentioned in her presentation, we're talking about ozone, we're talking about NO2, SO2, we're talking about various different chemicals outside, and not all of them can just be solved with an activated carbon filter. Sometimes they need a slightly different chemistry in the chemical filtration system so that it can work with a NO2 type pollution or an SO2 type pollution. And we add those filters into these kind of systems, and then they are connected to the either to a grill, or it can also be connected to an existing duct. So what you are able to do here is you are able to bring in fresh air, you're able to reduce the thermal load of that fresh air, and you're able to remove all the pollutants from the fresh air before it enters into the system. Therefore, what happens now to the office, along with the efficient cooling of the VRV, you're also bringing in fresh air that does not increase a lot of your electricity bills, maybe by 1% or 1.5% annualized, but at the same time, it improves your air quality drastically. Along with that, we also added indoor and outdoor air monitoring systems, obviously, not just to monitor and analyze. And of course, Lejo in the previous presentation explained a lot about how effective good analysis can be, but also to, manage on a day-to-day basis these systems that we are implementing. Right. So I will skip right ahead to what the conditions look like. So this is our office's outdoor conditions on the leftmost corner of your screen. We are in an industrial area. We have obviously vehicular pollution, and we have a lot of the other construction pollution that Mumbai has on the baseline. But in addition to that, we have this industrial pollution that brings in NO2, SO2, ozone in the presence of the sunlight, and all these other different pollutants that are also entering our office and are also hampering our office employees. So that on one end. On the other end, at the rightmost side, you see the comparison between a very fresh filter and a used filter. The use of this filter was not more than 4 months in the Mumbai outdoor environment, and as you can see, it has completely changed color and it is completely blocked. So it's not just about putting in a system, and in fact, even for your homes, it's not just about putting in a purifier or putting in a filter, but it's also to see what's the condition of that filter after 4 months, after 5 months, after 3 months, and what's the right time to actually change the filter. So the data from outdoor as well as indoor, the analytics engine, along with these solutions, we are able to identify almost 5 to 6 days in advance that, okay, the filter is about to choke completely, and maybe now is a good time to replace the filter. So let's not get into the quantitative impact of the fresh air, but in terms of qualitative impact, not just us, other people working in the office, the office that we share, the people that we share our office with, our clients, vendors, everyone, when they come to our office and they breathe the air, they say that it feels lighter. They say that, we don't feel that post-lunch lethargy. In fact, a lot of our employees realize that post-lunch lethargy is a myth. It's not that you had lunch and now you're feeling dizzy. It's because buildup of very high CO2 in offices that is probably causing you the dizziness and the sleepiness, and not actually the lunch. So a lot of these things were qualitatively observed in our office. We also observed, and a lot of people also pointed out, that spread of allergens or spread of common cold in the office is not as common as some other places where the air is completely airtight and packed and there is absolutely no fresh air to breathe. In fact, if your CO2 levels are 1500 ppm, every second breath that you take is someone else's exhaled air. So you're breathing someone else's air if you're in an office that has CO2 that is above 1500 ppm. And on an average, an office in India will have 2000 to 2500 ppm of CO2. In terms of the quantitative impact, not in terms of how the impact would be in case of numbers or absenteeism reduction, but purely in terms of how quickly and how effective these systems can be, and can be for any solution or at any space. however small or however big. You can bring down a 3-digit PM 2.5 to single digits in a matter of 1.5 hours, and you can bring down a 1,800 ppm of CO2 to approximately 700, 800 ppm of CO2 in a matter of minutes, 15 to 16 minutes. That's how easy it is. That's how effective it is. And then breaking it down to actual numbers, and right after that I will show you a live reading of our office, so that you can see it in real time. But the office of 6,000 square feet with 77 people working across the office, we were able to bring down PM 2.5 to 5 micrograms, PM 10 to almost 20, the CO2 from 1,500 to 2,000 to 506. And the cost of all of this, if I look at running it for 2 years, which is an average tenant time for in a leased office, minimum they are in that office for 2 years. If I look at the cost of the clean air that I'm providing to my employees, it comes out to 6 rupees per person per day. That's approximately the cost of half a cup of tea in Mumbai. And it's okay if you're giving your employees a cup of tea every day, but if instead of that, if you're for the same price, if you're giving them fresh air, that's a much better and much bigger perk for your employee, and their health will probably thank you much more after that. So at this point, my presentation is over. I mean, I'm happy to just very quickly, I just want to share once the data for our own office. So as you can see, I hope my screen is visible at this point. But as you can see, our office, so what you can see, there's a carousel. So right now the R&D area data is visible. Now the production room data is visible. Then you will see the conference room, and then you will see the open office area. And you can compare it to the data outside, which is also being monitored by one of our systems. And you can see the difference. Like, as per the ISHRE standard, which is the strictest standard for air quality, at par with WELL and at par with RESET, they say that 15 micrograms and below is considered excellent. So even there, at some of our places, we've not reached excellent. We're still moderate. But even if we look at, say, 19 micrograms per meter cube or 20, as compared to what it is outside, 225, you are actually breathing an air that is much lighter. Similarly, if you look at the CO2 levels, approximately max to max in an environment, we have 700 to 800 ppm of CO2, which if we shut down the system will rise up to 2,000, 2,500 fairly quickly. So with that, I bring my presentation to an end, and thank you so much for your time today.